welcome you here to Effective Geodatabase Programming. I'm Colin Zwicker, and unfortunately my colleague Eric Cole was supposed to present with me fell ill, and I have found this gracious replacement in Rich Rue, my magnanimous associate. So we are going to present Effective Geodatabase Programming today for you. So let's jump right in. The purpose of this presentation is it has a lot of material, and I'm not going to talk to every single bullet point, right? This is some of this can be reference material for you when you get home to take a look at, to look up, and while you're reviewing your code. I'm going to assume that you have some understanding of what the geodatabase is. Who in the room is programming against ArcGIS Desktop with ArcObjects? Okay. And how many people are using the Pro Managed SDK to program against the geodatabase? Okay, a slightly smaller subset. Okay, cool. Well, we're going to talk about some of the patterns for both of those today, and give an introduction to the Managed SDK as well. And then we're going to go over some of the common questions, some of the things that have come in from support multiple times. And then we're going to go over a few of the top mistakes that have happened. So like I was saying, we're going to assume that you have some working knowledge of what a geodatabase is, that it's a data store for data, and our code examples vary from pseudocode across multiple different languages. We can all translate between them. That's not the important part. It's the pattern that we're talking about that's important. Like I said, there's a lot of content. We have a little bit of time. I'm going to try to move as quickly as I can. And you can use these slides as a reference afterwards. So what are we going to talk about today? Well, the first topic we would like to talk about is unique instancing of objects. Then we're going to move into a little detailed discussion about cursors in the geodatabase. We're going to talk about different types of caching with a geodatabase. These are both spatial and schema caches and how those can optimize certain workflows. We're going to talk about schema locks and how it's your responsibility as developers to manage those. Then Rich is going to give us an overview of the core data API. This is the managed SDK for Pro. And then we're going to come back to me and talk about some of the top developer mistakes. So jumping right in, unique instancing of objects. So the geodatabase will have at most one instance of these objects instantiated. This is similar to a COM singleton model, like our workspace factories, but it's managed by the geodatabase instead of by COM. Some of the things that are unique instance are data sets like tables, feature classes, and feature data sets, or workspaces or versions. So in ArcObjects, there's often many different ways that you can access a particular thing, and all this is really saying is that no matter which way you access it, it's still the same object. So if you make a change to one of the ways that you opened it, it will affect all of the opened objects. So let's take a look at what that looks like in code. Here's an example where I have a versioned workspace, and from the versioned workspace, I ask for get default version, and I keep that as my default version. And then from the version workspace, I use a different method, a more generic method, to find version. And again, I ask for the default version. And now I have two versions, right? Default 1, default 2. And if I ask for equality on those, because of unique instancing, they are identical. They are equivalent. So you can see that it returns true here when we check that. Another example of this would be opening feature classes. So from the workspace, we can call open feature class and access our boundaries, state boundaries class. We can also access that with a fully qualified name, right? By opening it with its fully qualified name from an enterprise geodatabase. And the third pattern to open this could be to open the feature data set that contains it, the United States data set, and use the iFeature class container, accessing it by the get class by name and returning a third reference to that feature class. But as we see at the bottom, every way that we open that feature class, it is still equivalent. They are all exactly the same. The geodatabase is never handing out multiple references to that class. Can anyone think of one example where my bottom example is not true? I just said it never happens. Good. So one example would be if you were not connected as the DBO owner, and the first class open actually opened your schema's feature class named state boundaries, and then you explicitly opened a second class owned by another user. These are two different tables in the database. The geodatabase opens those as two different instances. Okay, there are some special cases. Rows and features are one of those. The geodatabase only uniquely instances those inside of an edit session. So we take a look at our code here. We have open feature class again. From the feature class, we call getFeature, passing in the object ID of 1. We keep that as feature 1. We then do the same thing again, except for keep that as feature 2. And what you'll see is that those two features are not equivalent. They are separate references to the feature. Okay? Then what happens when we start an edit session? You'll see here I use a multi-workspace edit to start editing. And then I do exactly the same code again. I call getFeature, passing in the OID, getFeature, passing in the OID, and I compare the reference to the two features being returned, but because I'm inside of a geodatabase edit session, those two features are identical, right? They are uniquely instanced inside the edit session. So this only happens inside of an edit session. So the next topic we want to talk about is cursors. So there are really 4 types of cursors. 3 of those types of cursors are class-based cursors. Those are search cursors, update cursors, and insert cursors. And the 4th type is a QueryDef cursor. This is not a class-based cursor. So what's the difference between the two? Why do I keep saying is it class-based or not? For the rows returned from the class-based cursor, you can still get a reference to the table from which they came. But for the QueryDef cursors, there is no reference hooking back the row that's returned to the table. Okay, so let's take a look. Here I have some code where I open the parcels table. From the table, I create a search cursor, passing in no query filter and recycling true. That's the last Boolean. From that cursor, I ask for the next row. And from that row, I ask get table. Right? And you'll notice that in the comparison of the rows table and the original table, they're equivalent. Right? I got the same reference back from the row as the table which I got the row. It's basically saying that it's a row-based cursor. It's a table-based cursor. Okay, in the second example we walk through, you can see from the workspace I'm creating a QueryDef. I'm setting the tables that are going to participate. In this case, it's a single table, but oftentimes this is a join or multiple tables. And now you're starting to see why it's not a class-based cursor. So I call evaluate on my QueryDef. That gets me back the cursor, and then I ask for the next row. And in some very careful exception management, I try to ask for the table from that, and I get an exception. That's because this cursor does not have a reference back to the table. Let's talk a little bit more about each of the cursors. So the search cursor is a class-based, or is a table-based cursor, and it is like the workhorse of the cursors, right? It's the most common one, and it supports both retrieving rows and modifying those rows. You can get search cursors from the iTable interface or from selection sets by calling search. But also internally, we use the search cursor to implement many of the methods. For instance, the table.getRow internally opens a search cursor every time with a filter based on the object ID that you passed in. So one of the interesting things about search cursors is that if you're inside of an edit session, the query may actually be satisfied by the cache, either a spatial or a feature cache or the object pool, the editing cache that we keep in the geodatabase. This is not true of the other types of cursors. Only search cursors have this behavior. when it's used within an edit session, the creation of the cursor may cause any of the cache rows to be flushed. And this is so we can see exactly what the query will give as a result at that time. So what does that really mean? Well, that means anytime you open a cursor, you might need to check the exception, because we're going to write rows to the database. And if the database fails, that's a point of failure for you, and you should check for exceptions at that point. Right? On the cursors, we can have, we can call store or delete on the rows that come back from them, but we cannot use insert row or update row or delete row on search cursors. So the second type of cursor is an update cursor. We have a pattern that's pretty standard. We call next row, and then we call update row, passing in the row once we've modified the values. We call next row, we pass in that row to update row, and et cetera, et cetera, et cetera. Some of the APIs from which you can get update cursors are again table and iSelection set 2. These cursors are never satisfied by the cache, only the search cursor was. The resulting rows can be modified, but they're modified by passing it back to the cursor, i.e. iCursor.updateRow and iCursor.delete. They cannot be mixed with store and delete calls directly on the row. So what happens if your class requires store events? Well, internally, if the class requires store events, the geodatabase will convert that update cursor to a search cursor. And the equivalent update row or delete row will effectively be row.store and row.delete. So how do you know if your class requires store events? Well, the first big flag is if the thing that you want to check is if the feature type of the feature class or the table is not of type simple, right? So you can think of things that participate in geometric networks or relationship classes that require forward messaging, like composite relationship classes. These are things that rely on these events, the store events, to trigger additional behavior. And if we bypass those, we'd be breaking those contracts. So the classes say they require store, and the geodatabase will help you correct that. Even if you open an update cursor, internally we'll turn that into a search cursor for you. So there are a couple of other cases where update cursors can return errors. If we try to update a row that's not at the current position, or if we pass a row that we got from a search cursor to the update cursor. So what are some of the best practices, right? This is a best practice for all cursors, but is particularly important for update cursors, and that's not to scope your cursor across edit sessions. This was a very important concept for versioning. It still is. However, it was so important that we decided to block that pattern with an error. So now I think it was ArcGIS 10.0 and onwards, you will get a hard error if you attempt to use a cursor that spans an edit session. Why was that important? Well, the versioned edit was based on a state, and if you move that state by making a new transaction, then you could lose the updates in that edit session. So always scope your cursor to the edit operation. The third type of class cursor was insert cursor. These are primarily used for bulk loading. The table interface can be used to create an insert cursor by calling insert. Its best performance is usually when you use buffering. And if the class does not support cursor, or does support events or requires events, then a search cursor will be used internally and you'll get no benefit. So what is buffering? Buffering is a parameter that's passed on the creation of the cursor. Use buffering as true. When that's set to true, you can ask to flush at particular intervals. So how often should you call flush, right? A rule of thumb that we say is about 1,000 rows is a good rule of thumb. Now, is that going to be true for every single data set? No. And this is where prototyping comes in. You should try what works best for you. Now, what do you mean what works best for you? Well, how many rows are you willing to lose if an error occurs on the flush, right? How much do you want to backtrack your work and correct for that? You do gain benefits, right? We're basically saying that we keep a cache locally, and then when you call flush, we'll write to the database. One of the other things you want to take a look at is to make sure that you're not negatively impacting yourself by having an active spatial cache. If you have that active spatial cache, we will take a hit on these inserts and maintain the spatial cache for you. So if you're looking for pure performance, make sure you don't have a spatial cache active. This last bullet is about making sure that you have correct error checking. I said that when we call flush, we'll write to the database, but it's possible that if you chose a large enough value, 100,000 or something, that's number out of the air, that the next call to insert row will fill our internal buffer and we'll be forced to flush. So you have to check for errors returned both on insert row and on your explicit flush call. Destructing the cursor will also cause a flush. Okay, the fourth type was these QueryDef cursors, and as I said, these are not bound to the class. QueryDef cursors have the behavior of always bypassing any cached rows. Activating the cursor, just like the search cursor, will cause any cached rows to be flushed. This happens for a QueryDef on the call to evaluate. Rows that you get back from QueryDefs cannot be modified. They do not support being called on store or delete like the search cursor did. Okay, an orthogonal idea is the idea of recycling cursors, right? So what are recycling cursors? It's a cursor type that allows you to reuse the memory structure on the client side when you return a row. This is both the memory that holds the row values and the objects from them, i.e. the geometries. Many of our APIs support returning recycling cursors, and you do that by passing the Boolean value of true. So these are some of those APIs. Internally, get rows and get feature, search, update on selection set and iSelection set 2, search and update, and the iTableWrite interface on update rows. All of these support returning recycling cursors. So here's an example where we call next row. Let's walk through it. We open a table, and from the table we call search with no query filter, that's the null, and then the second parameter is recycling true. So these are going to be recycling cursors, and they're going to reuse the memory. So we walk the cursor by calling next row and storing that in first row, and then call for the next row and store that in second row. And assuming we got 2 rows back, you might think that these are 2 different things, right? But because it's recycling and the memory's reused, by assigning it with the second row, you overwrote what the first row was, right? In memory, we reuse that exact same memory. A little tricky concept. Let's expand on it just a little bit more. Same table, opening our search cursor again, using recycling. It's a particularly important line here where I check the field index and store it before I access it. That is definitely a best practice. Don't do that in a tight loop. Then I say from the cursor gets the next row, and from that row I ask for a value, the geometry, and I keep that geometry as first geometry. And then I do the same pattern again from the row for a second row and get the second geometry. And because of recycling, even the geometries from these 2 rows, even though I'm holding on to them in my app, point at the same piece of memory. So don't be fooled by that. I mean, it can be surprising the first time you see that. So when should the recycling cursors be used? Well, it's really when you don't need to persist the row, right? If you are simply gathering some values off of that and then printing that out to something else, a report or something, or splashing those on the screen with draws, that's when you want to use a recycling cursor. Never return a row from a recycling cursor, because there's no way the person who's receiving that, the function, knows it was recycling, and you could change the reference out from underneath them. Don't edit recycling rows. But that being said, that within an edit session, the correct use can drastically reduce the memory consumption. So let's take a look at this example. This is some code we ran a while ago. These numbers show, 50,000 row table, 75 fields each. We're inside of an edit session, and we call search with recycling. When it is true, we walk through the cursor, returning the row each time. And that uses about 60 megabytes of memory. However, if we used a non-recycling cursor in this example, it uses about 3 times as much memory. So often what we see here is that someone will complain that their engine application is using a lot of memory. And the first thing we'll look for is if they're doing editing, okay, possibly they are caching rows that they shouldn't. But if they're not doing editing and they're just building some report, possibly they could be using recycling to reduce that footprint. So what's the opposite of recycling cursors? Non-recycling cursors. So these are non-recycling cursors basically use a new piece of memory for every row that's returned. Right? It's the opposite of recycling. You would get a non-recycling cursor by passing false to the property. When would you use a non-recycling cursor? Well, this is if you want to persist a reference to that row for some period of time or to return it from your function. It's commonly used to cache features. Some of the geodatabase APIs do require you to pass them a set of rows, and this is those rows should always be a non-recycling cursor returned row. And non-recycling cursors are what you want to be editing. Notice I used a recycling cursor inside of an edit session, but I didn't edit those rows, right? That was purely for performance reasons, memory usage. So when should I release a reference to a cursor? The answer is immediately. As soon as you're done with that thing, release it. Remember, we want to scope these things to the edit session, so release this thing as soon as you're done. Okay, what if I need a cursor inside of an edit session? Where should I create the cursor? I just talked about this, right? Scope it to your edit operation. Here is an anti-pattern. Don't do this. If you're gonna, don't do this. Where I hold the cursor across the creation, across the stop edit operation and attempt to use it again. This will now, in current software, return a hard error for you. Should I use a search cursor or to update rows? We have an update cursor, right? Yes. In fact, using the search cursor is fine, right? It's within an edit session and it's the recommended way, right? Because any spatial cache that we have or edited cache that we have will help to satisfy this cursor. So here's a little grid to help you understand when to use what. And it's a little counterintuitive at first, and we often pull this out when we have in-house development discussions. But let's just walk through the grid. Basically, if you are within ArcMapper Pro, and you're inside or outside of an edit session, you want to use a search cursor, because then you'll take advantage of any of the native caching that's happening. If you are in an engine application and using complex data, like a geometric network or a topology, search cursors. Those are things that require store. Now, the interesting case, if you're in an engine application with simple data, inside of an edit session, search. If you're outside of an edit session and you're looking for the ultimate amount of performance, update or table write will be the patterns that you want to follow. So this is a good one to use as reference when you go back. So let's talk about caching in the geodatabase. Okay, I've talked about a spatial cache already a couple times, but what is it? Well, it's a client-side cache of the features in a given extent. This was introduced in ArcMap 9.0, and ArcMap natively uses it for many of its patterns. It can really speed up the queries because basically you're taking out the round trip to the database after you fill the cache. Those search cursors can be fully client-side satisfied. Well, when to make use of it, I just went over some of that, right? If you're making many spatial queries within a common extent, that's what you want to use. What if you're doing an attribute query? Right? The spatial cache won't help you, right? It is only spatial queries. Okay, so how do you fill these things? How do you create one? Well, there's an iSpatial Cache Manager too. You can fill cache, you can empty the cache, and you can check if the cache is full. So here's that API as a reference. So what does this really look like? Here we have some parcel data, and I know I'm going to do something that's intense. I'm going to do 4 spatial queries in the same place, right? I'm going to build a spatial cache to do that. No, that's not the case. That's what my slide says. But if you're going to do like something that's intense, like snapping, right? And you know that you have a great amount of latency to your enterprise geodatabase. It's not even on site, it's across the WAN, right? Spatial cache is what you want to do. All of those queries to do the snap are now satisfied by the spatial cache instead of going across the wire and coming back every time. So I have these queries that I know I'm going to do in this specific area. I pass this envelope as where I know I'm going to be working. That red envelope becomes what I use to fill my cache in my query envelope in this example. And then I go forth and I do the work that I need to do. Okay, well, there's a second type of cache, a schema cache. Schema cache is basically a snapshot of the geodatabase's metadata about its tables. ArcMap natively uses it in many of its operations. One of those examples is opening map documents, but also operations like reconcile, things that know they're going to open a lot of tables. One of the things that it's based on is you having a static data model, right? If you are constantly changing or your application is changing the data model as you work with it, a schema cache is not the best thing, right? Because we are taking a cache of what the schema looked like at that time and assuming it's good. Okay? So this can drastically improve the performance of opening data sets, and it can be enabled on the workspace factory so that any workspace opened from that factory, i.e. all file geodatabases or all enterprise geodatabases that you open in that session, will benefit from that cache, from a cache, I should say. So here's the APIs to do that. You can see that some of the enable schema cache and is it stale? So it can become stale because we said this is really for static data models, right? And when should you use it? Well, you should use it if you know the operation you're going to do will open many tables. So an example is a geometric network or a utility model where there are a lot of classes that will benefit from having the round trip removed from looking for the metadata. Yeah, like I said, if you're going to open those tables either via the open patterns or with their name objects, we'll still utilize that local cache. If the cache is fresh, you can check in case someone else has made a modification, and you can refresh that cache as you need. However, it is your responsibility as developers to disable that cache when you're done. Otherwise, the workspace won't release itself correctly. So let's take a look here. We have a workspace factory, and we're going to cast to the iWorkspace factory schema cache interface. We're going to call open, passing in a property set and returning a workspace. And then with that interface, we're going to enable schema cache, passing in that particular workspace. And then we're going to go on to do our work, where we take the workspace, cast it to the feature workspace, and then open the tables, in this case, a single table. And then when we're done, we'll disable the schema cache. The benefit has already been gained, our table's open, and we keep that hot. So we talked about schema caching and spatial caching. The last thing I want to talk about is schema locks. Schema locks are taken every time we open a table. You get a shared read lock. And these shared read locks prevent other applications from modifying the data out from underneath your application, right? So as developers, there will be times when we need to promote those locks from shared to exclusive. And those times are when we want to make schema modifications. Right? Those exclusive locks are never applied automatically, nor are they removed automatically. So here are some of the operations that you might need to promote an exclusive lock for. Some of them are obvious, like adding fields. I'm clearly changing the schema there. Or anything that uses iClass schema edit. I'm going to edit some schema. But there's some things that are less obvious, like adding a code to a coded value domain. It will actually require you to have an exclusive lock on the classes that coded value domain is assigned to. And if you don't ensure that, a failure may occur when it can't promote the schema lock, and you'll see like class locked error. So this is a good thing to check. One of the other ones I wanted to highlight there is feature class load only mode. This is a mode in which you can put your class into that disables some of the indexing, which allows loading to be even faster. It requires an exclusive schema lock because you're doing a modification to the schema. Cool. Last point here before I pass it over to Rich. Just want to reiterate, exclusive lock means no one else can take a shared lock. It's our responsibility as developers to, when we go into that state, to make sure that on all exit points, including errors, we demote the exclusive lock, or no one will be able to open the table. So if you want to think about an application which is doing this, and you give the user a UI to walk through and say, hey, fill out all the information about this field set you want to add, do that before you promote to an exclusive lock. Let them do the slow piece first, and then keep the exclusive lock as tight around the individual call as you possibly can. And as soon as you're done with it, again, just like a cursor, get rid of the cursor, demote the exclusive lock. Okay.
Thanks, Colin. So today I'm going to talk for a few minutes about the managed SDK that's part of ArcGIS Pro. So ArcGIS Pro uses a managed SDK, but it does not use it internally. Internally, it's still using the same ArcObjects as before. That ArcObject framework, however, is not exposed to the end developer. What we found over the years with ArcObjects is, because it was such a low-level API, it was very easy to write bad code, to write dangerous code, to write code that either didn't work as well as it should or didn't work as quickly as it should. So what we did instead is we learned from that mistake, and we built a more coarsely grained API on top of ArcObjects. The coupling of your code is much less than it was in ArcObjects. You don't go down and write custom features and class extensions. Instead, you write at a higher level with Pro add-ins. So the API in ArcGIS Pro is DML only. What that means is it only does data manipulation language, only does queries. It does not do DDL, data definition language. So things like creating tables or adding fields or modifying any kind of data sets, those are not handled to the API. Instead, what you do is you use geoprocessing to do those tasks. So if you're writing a C# program, you can call out to the geoprocessing API and run the GP tool through the environment that way. If you have a standalone app, you can actually shell out and run from Python. Another one of the guiding principles behind all of this is we wanted to provide one way to do one thing, if we can, and not provide multiple ways to do the same thing. So just real quick diagram here. Your code, your client code, sits on top of the C# managed SDK. There's an interop layer there in between that and the ArcObjects down below. So we've gone through and added lots of things over time. One of the interesting things that Colin wanted me to point out is that at 2.0 we actually took out a routine called get path on the data store, and then we found we needed it back in, so we put it back in at 2.1, I believe. Yeah. Some of the more recent things we've done in the past year, since the last Dev Summit, we've had Pro 2.2 and Pro 2.3 ship. We've added support for sorting tables. We've added calculating statistics. providing access to archive tables, and also attribute roles, and one more that isn't listed on the slide, and that is plug-in data sources. So there is a longer talk tomorrow at 1 o'clock called Overview of the Geodatabase API, and that's in Mesquite G. I'm going to be going through this and more topics in greater detail than today. I'm allowed to plug myself, right? Okay, good. So a little bit of an overview picture before we get into some of the details. Typically, when you're working with the geodatabase, you start with a connector. Now, connector is an abstract class. It is a class that provides information about how to open a connection to a data store. And data store is another abstract class. Data store is something like a database or a geodatabase or a file geodatabase and so forth. The data store contains a collection of tables and feature classes. These are data sets. So you use the data store to get a data set. Then from that data set, you execute queries and you get the row cursors that Colin spent so much time talking about. And from row cursors, you can get the individual rows. So I'm going to walk through each of these steps in a little bit more detail. So I mentioned connector was an abstract class, and there is a whole set of different concrete classes underneath that. So just to highlight some of these, there is a database, by the way, getting old is terrible, database connection properties connector that allows you to connect to an enterprise geodatabase using an instance name, the version name, username, and password, and so forth. There's also a database connection file connector, which just takes a path to an SDE file. And likewise, there's other ones for things like a feature service database uses service connection properties, and there's a file geodatabase connection path, which allows you to open a file geodatabase. So you take these things and you instantiate a new data store. Now, data store, again, is an abstract class. The primary concrete subclass of that is called the geodatabase. So this is what you're going to be using most of the time. If you've got a file geodatabase, a feature service database, or an enterprise geodatabase, you have a geodatabase class. There are some other types of data stores. There's a file system data store, which is used with shapefiles. And there is a database, not to be confused with geodatabase, but a database is a connection to a relational database that has not been registered with the geodatabase. So a little bit of a subtle distinction there, but if you are not using a geodatabase, you don't have those extra system tables that we add, you can still connect to it and do certain operations. So once you have this data store, whether it's a geodatabase or one of the others, you use that to open data sets. The simplest of these is called a table. And a table is just a collection of rows, collection of fields. It supports search and select. Some of the different ways you can get a data set, you can open it directly from the geodatabase. You could also get one from a feature layer on your map or from a standalone table on your map. And most of the time, if you have a row pointer, you can get the table from the row. The one case where you cannot, as Colin already mentioned, is if you got that row from a QueryDef and not originally from a table. Now, of course, we're here for GIS, so probably the most interesting kind of data set is a feature class. So feature class inherits from table. It provides support for shape. So you're going to have one additional field on there that has a shape field in it. Again, it supports spatial queries and selections like before. The way to get a feature class, pretty much the same as before. You can get it from a geodatabase if you know its name. You can get it from a feature layer. You can get it from a row or a feature. So because feature class inherits from table, it's worth pointing out that you could always open a feature class as a table. You know, it's fully polymorphic and in your object-oriented way. Another kind of data set in the geodatabase is a relationship class. So a relationship class is a stored relationship between two tables. And that can be two tables. It could be a table and a feature class and a table, or feature class to feature class. You can specify the origin and destination, and you can also specify the cardinality. So you can have a one-to-one relationship or a one-to-many relationship. And those are both represented through the relationship class base class. So to give you an example, if you have a states table and a cities table, you could have a relationship class between them. Each state has multiple cities related to it. Now we also support many-to-many relationships through this attributed relationship class. This is a subclass, and unlike relationship class, it is implemented using an actual table in the geodatabase. And basically that table has just foreign keys pointing to the source and destination. So this is for, again, many-to-many relationships. Maybe you have a company table and a states feature class, and each state, of course, has multiple companies, and each company may have offices in multiple states. That might be an example of what you can do there. You can also add additional attributes to an attributed relationship class. So to go to my example, maybe you have the revenue that each company makes in each state as a attribute, as a field on the relationship class itself. Now, if you look at the definition, the object model diagram, or the list of properties in table and feature class, you notice it's maybe missing some information about those things. And the reason why is we've broken out a separate set of classes away from data sets called definitions. And what these definitions are is it's the holding place for all the information about the table. Things like, what are its fields? Does it have an object ID? Does it have a global ID? What are the names of those fields? And so forth. The idea behind this is that you can open a definition without opening the underlying data set. So this is just us reading the little system tables that we have and giving you the definition. So this is a lot faster than opening the core data set. So how do you get a definition? You can get it directly from a data set, so there's a get definition method. You can also get it from a geodatabase, either by name or just get a list of all of them. So kind of an interesting case there, you can say geodatabase.getDefinitions, and it says here table definition, right, the bottom line of the slide. That's going to give you a list of all of the table definitions. Then using C# and a link query, you could say, okay, I want only those data sets that have a global ID field. And then you'll get a smaller set, and then maybe those are the ones you want to open. So you can do that without opening every single table in the database to find the ones you need. Okay, so we're going to talk a little bit about queries. There are lots of different query techniques, and I'm not going to go into full detail about all of them, but the simplest one is search. You have one table, and you want to select some rows. You want to search some rows from that table. What this will do is as we've already talked about with the row cursors, you get back a row cursor. It can be recycling or not. Before we go on to talk more details about that, let's talk about select for a minute. Select allows you to pass in a list of object IDs and get back a lightweight selection. So this is great if you want to select features on the map. One of the other things you can do with a selection is you can combine selections. So you can say, do this query, do this query, do this query, combine them all together, select those features on the map with just a few lines of code. Now you can call search without a query filter, and that gets you a row cursor that has all the rows in the table. Most of the time, however, you probably want to use a query filter. And a query filter allows you to restrict the data that's returned. So the most obvious one is you pass in a where clause, so give me the cities where the population is greater than 1 million, right? You can also use subfields to only return those fields that you want. So depending on what you're trying to do, that could be less data that's brought back over the wire. Also support things like distinct clauses and order by clauses and so forth. If you have a feature class, you can use a spatial query filter where in addition to doing a regular where clause, you can also do a query that is spatial. So you can say, show me everything that intersects this polygon, for example. Once you get a row cursor, we've talked about these in great detail already. In the Pro SDK, there's 2 main methods on it that you need to know about. Move next, which positions the cursor to the next row in your data, and then current, which returns that next row. So typically what you do is you call move next until move next returns false, and do something with each of the rows that you get back from current. Worth pointing out that every time you call current, it does return a row, and that row in C# must be disposed. So you can use a using statement around that, or you can manually dispose it. But if you don't, it's going to keep that row around. A QueryDef. QueryDefs allow you to perform much more complex queries. You can run a query on a single table, or you can run a query on multiple tables. So you can essentially create a join between multiple tables in a single geodatabase. As Colin already pointed out, the rows do not return a table because they're not associated with a single table, right? It's associated with just this query. We also have a thing called a join. Now, a join it kind of provides a subset of the functionality in a QueryDef. It doesn't use SQL to the extent that a QueryDef does, but it does have the additional capability that you can do a join between tables in two different data stores. So whenever possible, if you're doing a query against a single data store, we're going to offload that query onto the server. Obviously, if you're doing two data stores, all that data has to be brought down to the client. We do the join on the client side. Worth pointing out that a join is read-only, but it will change as the underlying data is changed. So once you create a join, you can call getJoinedTable, and that gets you a table, which you can then do a search through to get the rows. Search, of course, returning a row cursor. You do not get a definition with a join because there's no actual table there in the real world. Finally, if you have a database, and as I mentioned earlier, a database is it's a relational database that is not enabled for the geodatabase. For these, you can use a thing called a query layer, and you can query based on a table or a table name or just a straight set of SQL, and that will also get you back a set of rows. So lots of different techniques to do that. In tomorrow's session, we'll talk more about when you use one versus the other. On the side of versioning, we do provide versioning support. We added this in 2.1, I think. From a geodatabase, you can get a version manager. You can then use that version manager to create versions, to get a list of versions, to connect to a named version, to connect to a named moment, and so on. Using the table, there's a method as well called table.differences that will allow you to get the differences between two different versions, the same table in two different versions. Once from that version manager, you also get the version object. You can use that to alter the version, so you can, say, change the owner or change the visibility. You can reconcile and post. I will point out that reconcile and post is a little unusual in that there's one method called reconcile, and it takes a reconcile description, which is there on the bottom left, and in that reconcile description, you say, I want to post. Because as you probably remember from the old ArcObjects days, you have to reconcile and then post. So we just do this in one operation. You say reconcile with post. Finally, just to point out, this is more reference material, but there is a document called Conceptual Help on the Geodatabase API that goes through in great detail all of the major classes and stuff. You can get to this either from the URLs on the screen or just from going from the Pro SDK homepage. In addition to that, we do have samples and lots of code snippets. With that, I'm going to hand it back to Colin.
Thanks, Rich. So what I learned was that Rich doesn't like passing in random property sets to open workspaces.
I don't.
And he didn't like having 45 interfaces on table.
I do not.
Okay, good. Seems like we're improving. Okay, so let's go on to the last section. We have top developer mistakes. Now, these are things that I've heard either from internal teams or gathered from tech support incidents. I hope to talk about these so that you don't have these problems in your code, and if you do, you know the solution. So the first thing I've already talked about, and that's the misusing or deceiving behavior of a recycling cursor. Basically, if recycling is true, we're going to reuse that memory, and don't be surprised if two objects that look like they might be different are actually referencing the same piece of memory. The next one is my personal pet peeve. It is using find field in a tight loop. You can see in the code snippet below, the person opens a cursor with a search and then walks the cursor, and each and every time they take the hit to ask the feature class to go find what field has the name variable, right? So which field is name, and then passes that index into the get value, and then does that every time for every row returned. The way to work around this is, of course, to ask what the index of that field is prior to entering the loop, and then simply pass that index. Now, Rich optimized this for you in the Pro SDK by caching that client-side regardless of how you ask for it the first time. So, getting better again. But if you're writing ArcObjects code, don't do this, okay? I'll hunt you all down. No, I won't. Okay. Next thing that always gets asked at the end of this thing is, I saw you releasing cursors. How do I do that? When else should I do that? I have added a little blurb here and given you an example in C#, how to manage COM objects within the garbage collection without forcing a full garbage collect every time. You can see here, if the variable is not null, then I call Marshall COM release object, passing in that object, and I do that until the return is 0, right? Or if it is greater than 0. So anything that holds a reference open to the workspace is something that you should release. So normally we see this in our testing by things not cleaning up afterwards, meaning we haven't done our correct testing in removing the release or the objects that we have referenced. Tables, feature classes, and workspaces are some of those things that you should do. Cursors and rows and features as well. It's not an exhaustive list, but those are the things you should look at first. Okay, trying to do DDL in an edit session. This is probably the most requested idea on the ideas site, and we will not do it because of this problem, which is what on almost all RDBMSs, when you do DDL, we commit. Meaning you no longer have any undo redo, and whatever was there is there forevermore. Thank you. So this is something, if you need to provide this behavior in your own application, you will need to manage that expectation. You'll need to stop the edit session and abort or commit, make the modification, and then reestablish your edit session. So what about problems that cause infinite loops in your code? Here's one. What if you are in an event for a store-based item and you call store? It will of course fire the event and you'll get right back to your own reactive behavior. So basically, if you're in a store-triggered event, don't call store on the row or the feature. Okay? Otherwise, you'll just be sitting there watching your add-in, waiting for ArcMap to spin. Slight caveat on that. Also on create feature events, don't call store, because that's a store-triggered event, but be careful in modifying the geometry of those features, specifically for things that are complex behavior like geometric networks or topologies. The network, for instance, has made a decision based on the original shape of the feature, has already updated some of its index, and if you change it here, you will end up with unexpected behavior. So don't do this. Well, this is something I'm definitely guilty of. It is where we have given multiple ways to do something, and one of them is easy, so I'll just call that in a loop. This is calling get features rather than calling get features, right? Asking for an individual one and then moving to the next ID and asking for the next one and asking for the next one, instead of passing in a set and asking for them all at once. Why is this bad? Remember I said that getRows was implemented with a search cursor. That means every time in this loop that I call getFeature, I'm opening a new cursor on the database. That's bad. Just pass us the array and let us do it once. Okay? If I could go back in time, I would remove getFeature. Okay. Here's an interesting one that came from an internal team. They thought that by holding on to the name object, they would keep the table reference open. This is not true. The name object is simply a moniker. It's a shortcut that says, hey, go open that thing. It has nothing to do with the table reference. If your application needs the table to be open, open it and hold on to that reference. Don't assume that the name object will do it for you. I will say this is usually what I get emailed, saying that the geodatabase can't create classes. I don't understand what's going on, Colin. But it's careless reuse of variables, right? In this example, I have a fields collection that I'm building up, and I set the properties on the field edit for the name, object ID, and the type, and then I add that to a list, add fields. And instead of doing what I should do, which is say, new field class, I simply reuse that variable and overwrite everything that I've already added to the collection. So effectively now I have two fields in my fields list, both of them called name, both of them with a type of string. And if you are trying to use this to create a feature class, the required fields is an object ID, and we will fail, right? Because you've basically told us to create a feature class with two string fields. So this is just, careless. It will compile, it will run, but it won't work. So just be careful about, instantiating those things that you're going to pass into other collections. Third line down, new field class. If you put that after the first add field, you're fine. Or if you change the variable to the second time you use field edit to like field edit 2, you'd also be fine. So this is a little bit of a add-on to that. There are some things which are obvious when they change the persistence, like calling class add field or maybe even fields edit.add field. But there are other things that are less obvious, like domains and indexes. So some operations trigger DDL and others do not, and you'll have to be careful when you're writing your code to make sure which ones those are. This is a question I get often asked. Like when I'm creating a relationship class, why don't I just turn on all of the eventing? Right? Well, if you do that and you don't have a use for those events, you're asking us to generate events unnecessarily, raising the cost for everything. Therefore, only enable those events that you require or that the class itself requires. Composite classes require forward messaging. Nothing else in ArcGIS takes advantage of messaging without doing custom code. So unless you're writing the code, you don't need messaging. One other thing I'd say is that, if that is required, if you open the destination class before you do the edits, we don't have to open it for you. And you can use the schema cache to do that in an optimal fashion and therefore improve the performance. Okay, so some bonus content for this year. Right? Stuck this in at the last minute, but ArcGIS Pro 2.3 has introduced a couple new concepts in the geodatabase. The first one I want to highlight is contingent values. On the left, you see our design view for contingent values. It is effectively a way to link domains together, where you can make codes from one domain dependent on codes from another domain. So in this example, I have a field group for two fields, material and outside diameter, and you see basically the list of all of the valid combinations. So the material would have a domain with composite, ductile, plastic, ABS, and the outside diameter would have a domain with the full range of all possible diameters. And what contingent attribute values do is allow you to say, well, for values in the first field, limit the options my editor has in the second field. So on the right-hand side, we can see that in the editor, the user has chosen composite, and they've only been given two possibilities. 4 and 6 inches. So this is a simple example. It's 2 fields. You can build these as large as you want and as complex as you want. But basically it allows you to narrow down the valid values based on another domain value. Okay? Next one is attribute rules. Rich touched on this. The SDK added it. It has been enhanced and continues to enhance. They are rules that are stored with the feature class in the geodatabase. They use arcade scripts to automatically populate fields or constrain edits, or possibly create error features during a validate operation. At the bottom, I just give an example that calls a database sequence and generates a user-defined unique key, a string ID pattern, and assigns that, based on the intersection of some other features in that database. Okay? Arcade's a very powerful language. It continues to grow. We add things each release as Arcade supports more. So keep an eye out for this. I will say, as the last anecdotal thing, I have never seen my developer laugh so hard as the first time I tried to write reactive behavior with attribute rules. It was surprising what happens in a truly reactive system, and he thought that was hilarious. So just a heads up, prototype these rules. There is a pattern for which you can export them and import them, and I suggest that you be careful making the decisions that you want for what they will do and make sure it works for your workflows. So that's the last thing I wanted to talk about. Take the survey. I will plug Rich's session again. There's also an Arcade rules demo theater tomorrow, as well as some other Pro SDK things and the road ahead. Thank you.